Kick out dirt.
That is awesome.
Just cruised over everything from the slippery AstroTurf over that rubble, the hay, no problem. It was really great.
That's amazing.
One try.
But as Rex takes a second spin on the course, the need to ensure that the driver is well protected becomes evident.
Coming out here today and seeing this thing perform on our obstacle course, we're certain this is the way to go.
Certain? After watching his likeness get squashed on its tiny head, Zaz might have something to say about that.
Those rollovers that, you know, is just kind of funny with the little Rex. That's not going to be funny when there's a person sitting in that thing.
Coming up, Terry goes back to welding school.
This is going to take a while.
And later, the bigger they are, the harder they fall.
This vehicle might not even stand up.
Our team is attempting to build an all-terrain six-legged vehicle capable of navigating areas wheeled vehicles can't. Not an easy task. After finding an expert in hexapod technology, the guys got a quick look at what Hal's small-scale model can do and are now going to attempt to build the world's first legged vehicle capable of carrying a human. Their version of the six-legged robot will be configured like an SUV of today. It will have a chassis, batteries, drivetrains, and a driver's seat, with the major difference being legs, not wheels. With so much to do, our prototypers need an organized plan. So it's back to the concept table to try to divide up this monumental build.
I'll do the chassis and I'll make sure that that's all sussed out as far as loads and torsion points.
Joe and I will look at the powertrain and the battery management.
So I'm going to be dealing with the legs, and the weight is really a huge concern for me.
Are we going to need to have any safety mechanisms in here?
Safety is going to be critical for this thing. I mean, these legs flipping around, they could take your head off. We are all going to have to monitor the safety of this very carefully.
All right, do it. Get cracking.
And they're off and running. Terry's part of the build, the chassis, is quite a daunting responsibility, especially considering the 2-week time frame. So he and Zaz head over to Spec Design for a meeting with senior mechanical engineer John Carver.
So I laid out some basic components before you guys got here.
This project is going to require a ton of CAD. That's computer-aided design, and that's modeling the structure, selecting out what material everything's going to be made out of, running analysis to make sure that all the struts and joints and so on are strong enough.
Big thing on this is going to be weight.
Sure.
We got to get the weight to be absolutely as low as we can possibly get it.
The target weight of the chassis is set at 400 pounds, and John thinks by using a light metal like aluminum, it might be possible to bring the weight down even lower.
I might even be able to beat it by 50 pounds or so.
Satisfied they're on the right track, Terry and Zaz head back to the island so John can get started with the CAD for the chassis. Being a leg man himself, Mike was the obvious choice for the leg design on this build. The 6 appendages are crucial because of the many different duties they'll be required to perform.
Well, they look simple, but there's a lot that goes into these legs. For one, they have to be strong enough to hold the whole vehicle up, so they can't break. And then they have to have some compliance. So I have to have a little spring in the step to cushion the ride, but also spring the vehicle forward. And then on top of that, if they're too compliant, it'll flip over. So they have to be nice and stiff in that direction.
It's up to Mike to select which material is going to give him the best chance for success.
It looks like the one I'm going to go with is carbon fiber.
Carbon fiber is an advanced composite material, best known for its strength and low weight. An ideal choice for the construction of aircraft, satellites, and walking 6-legged all-terrain vehicles. Besides being lightweight, the advantage of using carbon fiber is its strength and flexibility.
It's really stiff in that direction, so it's really, I can't even bend this. But then I clamp down on the other sample. Now I hold on. And you see it's really flexible.
Feeling the urgency to get the legs designed, fabricated, and on the vehicle for integration, Mike starts crunching some numbers. He computes that the best solution will be a 3-foot-long leg that is 1 inch thick at the top, tapering down to just 6/10 at the bottom.
Our legs taper down smaller because you don't want that mass at the end of it because that's more to move. And so our robot's going to be exactly the same as in nature.
And like any good scientist, Mike's got to test out his concept before moving on. So he mocks up a small test version of the leg and crams it in a vise to get an idea of how much pressure the little leg will withstand.
That's a lot of force on this little leg.
Mike's embarrassing high-pitched squeal. But with strength and flexibility like that, it's a squeal of approval.
I think we're in business. All right.
Meanwhile, up in the lair, Joe and Hal are on the way to another solution, this time for the control system. They're developing a cool way for the pilot of the vehicle to steer. So Joe's doing what he does best, hacking up electronics. Or in this case, an old-school video game joystick, which he'll use as the controller.
We really want this thing to feel like you're driving something, and when you're sitting in this big robot, it's sort of going to feel like you're in a tank. This thing's going to be moving around, the legs are going to be spinning, so having, a big arcade joystick like this moving around really is going to feel substantial, and that's really what we want.
After soldering the final pieces onto a circuit board, Joe's fired up and ready to go.
Should we try to test it out?
Yeah, let's do that.
And Hal's Little Rex is the perfect guinea bot for the trial run. So they head outside to give it a whirl. If Joe's joystick can steer the Little Rex, the next step will be scaling the system up to the drivetrain of the full-size machine.
All right, that is button number 3. Yeah.
Good.
I hope it goes forward. Yeah.
Awesome.
Joystick control.
Look at that.
And just like that, Joe is now in control as he maneuvers the Rex across the parking lot.
So we have our arcade joystick. We can push forwards, backwards, left, right, control the robot.
It's safety first on Prototype This. So Joe has installed a dead man switch, which will kill the power in case of emergency.
Exhaust is falling off. Better use the dead man switch.
When he lets go of the switch, Rex stops dead in its tracks.
Stop. All right.
Let's hope this is the last time the switch will